Hello friends, how are you? Today we are going to discuss two very IMP methods to solve the complex network. Among them, very first is parallel axis of symmetry and second is perpendicular axis of symmetry. Generally in JEE NEET exam we are given some complex networks and we have to solve them. Sometimes you try to apply Kirchhoff laws, you try to do a successive reduction method, but even though you won't be able to solve those networks. So for that, these two are very powerful tools: parallel axis symmetry and perpendicular axis of symmetry. First of all, uh, let me tell you that if you go through JEE and NEET books, there are n number of pages given on this two theory, parallel axis and perpendicular axis symmetry. They have given lot of explanation. What is this? How it comes from? And they have made it very complex. Instead of that, what I'll do is I'll give you a very short and brief explanation on what is parallel axis symmetry and what is perpendicular axis symmetry. Instead of going inside like how to apply this, what we will do is we will apply it on any particular network and then we will try to solve the network. So first of all, we will be needing one complex network. So consider this network. Consider this network. Say each resistance is having value R. Everywhere you are given resistor and the value is R. Okay, over here and over here. Suppose this is point M and this is point M dash. Each resistor is having value R. I'll draw same network this side also. So okay, this is the given network, and suppose you have to find the equivalent resistance between M and M dash, M and M dash. Okay, now you can solve this network by either parallel axis symmetry or using perpendicular axis symmetry, or you have to use both. First of all, how to decide? First of all, how to decide which is parallel axis and which is perpendicular axis? First of all, I have to decide which is parallel axis and which is perpendicular axis. Now, you have to find the equivalent resistance R between M and M dash. Means current will flow in this direction like this. Over here, same situation, I. Okay. Now, this is a direction of current flow. If you select the axis M dash, which is parallel to direction of current flow, then it is parallel axis. And if you select axis, suppose I'll give this name X and X dash. If you select X dash, in that case this axis is perpendicular to direction of current flow. Means these two naming, parallel axis and perpendicular axis, these two are based on direction of current flow. Is it clear now? So if you want to apply the parallel axis symmetry, in that case you have to select an axis which is parallel to direction of current flow. And if you want to apply the perpendicular axis of symmetry, in that case you have to select the axis which is perpendicular to direction of current flow. Okay. Now in parallel axis symmetry, what you have to check is symmetry upwards and downwards. Now consider this point M, this is point O, and this point M dash. So we have symmetry upwards as well as downwards, because you see this point and this point. Suppose this is point A, this is point B, this is point C, point D, point E, and point F. So between these 2 points you have resistance R. Similar case, between these 2 points you have resistance R. Okay, these 2 points are symmetrical. These 3 points are symmetrical, but you have to consider this B and E, C and D. So in such case, you can fold the network. What you can do is you can fold the network. Suppose this is your network, okay, and this is your parallel axis. In that case, you can fold the network from the axis. So from this M dash, you can fold the network. Okay, this is the way you can do it. Suppose this is parallel axis, then fold the network. So if you fold the network, this F and A, these two will be overlapped. E and B will be overlapped. D and C will be overlapped. So your new network will be like this. Consider this point M, this point O, and this point M dash. Okay, this is point B. Over here, one more point A. Over here, C. Now, if you fold the network, this A and F, these two will be overlapped, means A is equal to F, and this R and this R, these two will be in parallel, because the new network will be like this. Okay, because this R is between M and F, so now F is equal to A, so this R is between M and A, so M and A, these two are in parallel. Similar case, this R is between A and B, and this R is between F and E. So when you fold the network, B and E, these two will be similar. So this R will be between B and E, like this. Okay. So this resistor and this resistor, these two will be in parallel. Okay. Similar case, this and this, these two will be in parallel. This and this, these two will be in parallel. This one and this one, these two will be in parallel. Okay. So if you draw the resultant network, what you will get is R by 2, 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 and R by 2. Only this 2 will remain R. So M, O, M dash. Clear? Okay. So this is how you can reduce your network. So the resultant will be like this. This one will become R by 2. This R will become R by 2. This R also becomes R by 2, R by 2, R by 2, R by 2. Only these two resistors have the value R. Okay. Now, how to solve this network? Because now you cannot apply parallel access symmetry. From parallel access symmetry, you can reduce the network up to this point. Is it clear now? So, in such cases, what you can do is you can apply the parallel access symmetry. Now, in parallel access symmetry, if you consider the name, this is A, B, C, D, E, and F. Okay. Now, this is direction of current flow, and x dash is the axis which is perpendicular to direction of current flow. Now, here also left and right you can see the symmetry. In perpendicular axis symmetry, what you can do is the points, mark my words, the points which are on the perpendicular axis, points which are on the perpendicular axis, you can join them. Suppose point B, this is point O, and this is point E. You can join these 3 points. Means I can reduce the network like this. Earlier it was like this. Okay. Earlier it was like this. Now what I can do is I can join this point B, point O, and point E. So instead of this connection, I'll join over here, and this point, this will come here, this E. So what you can do is you can join over here and like this. Okay. So this is reduced network. This is point M, O, M dash. This is A. What you have done is you have joined point O is equal to B is equal to E. You have joined this 3 point. So it is very simple. If you found parallel axis symmetry, then you can fold the network, and if you found perpendicular axis symmetry, in that case points on the perpendicular axis you can join them or you can overlap them. So point B, O, and E. So I have joined them over here. Now sometimes, as I mentioned, sometimes what you need to do is you have to apply both parallel axis symmetry and perpendicular axis symmetry in the network. Okay. Consider now consider this situation. Suppose you are given this circuit and you have to find the equivalent resistance R M M dash. Over here you have applied parallel axis symmetry and you have folded the network. So this is M, M dash, O, R, R, and remaining resistors are having value R by 2. Now you cannot apply parallel axis symmetry once again in this network. Okay, you cannot go with a successive reduction. So what we can do is, this is a direction of current flow like this. Okay, so what I'll do is I'll apply this x dash. I'll apply perpendicular axis symmetry over here in this network. So what I'll do is this point, suppose I'll give name A. I'll join A and O because this network is having symmetry about the x dash. So my network was like this. Earlier R R by 2. This one is R by 2. this one is r by 2 and this one is r by 2. Same case, r by 2 and r by 2. Okay, this is O and A. Now from this perpendicular axis symmetry, what I'll do is I'll join this A and O. So this r by 2 will come in parallel and this r by 2 will come in parallel over here. A is equal to O. So r by 2 and r by 2. Is it clear now? This r by 2 and this r by 2 are in parallel. This r by 2 and this r by 2 are in parallel. Okay. Now you can use method of successive reduction. Suppose this is point M, this is point M dash, say this is point B and this is point C. So between point B and O, two resistors are in parallel and value of each resistor is R by 2. So equivalent of this two resistor is R by 4. Same case between point C and O, you can put equivalent resistance and that is R by 4. So M, O, M dash, R, R. Okay. Now R by 2 over here, R by 2. Okay. This is point B and this is point C. Okay. Now between C and O, R by 4. And between point B and O, R by 4. Okay. Now consider this part M, B, O. You have R by 2 and R by 4. These two are in series. So M, O and M dash. This is R. Okay. So R by 2 and R by 4 are in series. So R by 2 plus R by 4 means 3 R by 4. So this resistance is having value 3 R by 4. Similar case, consider this path O, C, M dash. R by 4 and R by 2 are in series. So you will get 3 R by 4. Okay. Now 3 R by 4 and R, these two are in parallel. So suppose R dash is equal to 3 R by 4 into R upon 3 R by 4 plus R. So 3 R square by 4 upon, take 4 as LCM, 4 plus 3 7. So you will get 7 R by 4. So 4 and 4 will be cancelled out, R cancel out. Answer is 3 R by 7. So between point M and O, you have 3 R by 7. Similar case, between points O and M dash, you have 3 R by 7. And these two are in series, means equivalent resistance is R M dash, that is 6 R by 7. Okay. So in such a network, you have to apply parallel axis also, as well as perpendicular axis, and after that method of successive reduction. So friends, please let me know in comments how you find this network solving technique. Do you need to know anything else or something more, or if you want more number of problems for practice, then you can message me on my WhatsApp number. I will send some of the problem statement for your practice. Thank you.